Let us find the roots of all minimal polynomials of GF16 elements. So GF16 elements are 0, 1, alpha, alpha square up to alpha raised to 14. So these total are 16. Alpha is a primitive element whose powers represent elements of GF16. So here you have to remember that alpha raised to 15 is equal to 1. This you have to remember, that alpha raised to 15 is equal to 1. And x raised to 15 minus 1 will equal to f1x into f2x into f3x likewise. These are f1x, f2x, f3x are the minimal polynomials whose roots are the elements of GF16. So whose roots are amongst these from 0 to alpha raised to 14. So we have to find which are the roots corresponds to f1x, which are the roots corresponds to f2x, f3x, and how many f1 how many fx are there for x raised to 15 minus 1. So the minimal polynomials are the products or the factors of x raised to 15 minus 1. This 15 comes from 16 minus 1 and alpha raised to 15 is equal to 1. This you have to remember. If it is g of 8, then x raised to 7 minus 1 and alpha raised to 7 is equal to 1. So let us take alpha first. So in this you have to skip 0 and 1 because they form single or their minimal polynomial has only one root, that is 0 and 1 only. Amongst alpha to alpha raised to 14 we have to find the conjugate set. That means how many elements correspond to the roots of say a single minimal polynomial. So take first alpha, then you have to find its powers. Powers should be like 2, 4, 8, then 8 2s are 16, 16 2s are 32, 32 2s are 64 likewise. These powers you have to find of alpha. So alpha, then alpha square 2 power, then alpha raised to 4, then alpha 8, alpha 16, alpha 32, alpha 64. Likewise you can go further. Where you have to stop you will come to know in the next line. So if alpha, then alpha square, then alpha raised to 4, then alpha raised to 8. This much you can write because you don't have to disturb alpha up to alpha raised to 14. So it is alpha raised to 8. Now alpha raised to 16 you have to modify it because alpha raised to 16 is not the element of GF16. It has the elements up to alpha raised to 14. So alpha raised to 16 you can write it as alpha raised to 15 into alpha, right? Alpha raised to 15 into alpha. Then alpha raised to 32 is alpha raised to 15 square into alpha square. 15 2s are 30 and 2 is 32. This is 15 plus 1 16. Alpha raised to 64 is alpha raised to 15 raised to 4. 15 4s are 60 and alpha raised to 4. Why alpha raised to 15? Because alpha raised to 15 is equal to 1. So and that is needed because we are the Gauss field is like it follows mod operation. So for doing that we are putting alpha raised to 15 or expressing it in terms of alpha raised to 15 and other powers. So alpha raised to 15 no. So alpha raised to 16 is equal to alpha raised to 15 is 1, that is 1 into alpha. Alpha raised to 32 is alpha square because this is 1. Alpha raised to 64 is alpha raised to 4. So you can you have written is alpha, alpha square, alpha 4, alpha 8. But alpha 16 is equal to alpha. Alpha 32 is equal to alpha square. Alpha 64 is equal to alpha raised to 4. So you are observing that from alpha raised to 8 it is repeating. So here you have to stop. You have to take the elements only alpha, then alpha square, then alpha 4 and alpha 8. These 4 are the roots of single minimal polynomial. These 4 are the roots of one minimal polynomial. Okay. So you have covered alpha, alpha square. 3 is not there. So next term will be 3, alpha raised to 3. So you will take here alpha raised to this is the page. So alpha raised to you will take alpha raised to 3. Then its powers will be 2, 4, 8, 16, 32, 64. So alpha 3, then 2 power, 4 power, 8 power, 16 power, 32, 64 of alpha raised to 3. So it will become alpha 3, 3 2s are 6, 3 4s are 12, 24, 16 3 are 48, 32 into 3 is 96, 64 into 3 is 192. After that, you have to write alpha 3, alpha 6, alpha 12. 24 is not there because elements of G of 16 are up to alpha raised to 14. So 24 can be expressed as alpha raised to 15 into alpha raised to 9. 48 can be expressed as alpha raised to 15 raised to 3. 15 3s are 45. Then remaining is 48 minus 45 is alpha 3. So alpha 3. Alpha 96 is 15 6 are 90 into alpha 6. Alpha 192 is equal to alpha 15 into 12. Calci में you can do it in calci. Alpha 15 into 12, that will be I don't know, alpha 15 into 12 you can do in calculator. So the remaining power remains is alpha 12. Okay, I think it is 180 plus 12 is 192. Yes. Okay, after that alpha 3 6 12, 24 alpha 15 is 1, so that is equal to alpha raised to 9. Alpha 42 48, this is equal to 1, so that is alpha 3. Alpha 96, this is equal to 1, so alpha raised to 6. Then alpha 192, that is equal to alpha 12, because this is equal to 1. Alpha 15 is 1, 1 raised to 12 is 1. So you will get alpha 3 6 12 9. Alpha 24 is 9. Then again you are getting 3 6 and 12, that means it is repeating from this. So you can take 3 6 12 9, each set of conjugates or set of the elements which belong to same minimal polynomial, or which are the roots of one minimal polynomial. Now you have covered 4 is already covered. 4 is already covered in here 4 is covered, 2 is covered, then 3 is covered, remaining is 5. So 5 you have to take alpha raised to 5. Then its powers will be again 2 4 8 16 32 64. 5 2 4 8 16 64. So here 16 32 is remaining, I think 32 into 5. So I have directly here I have taken 64. So 32 into 5, 160. So 160 it should be, where is that pen? So it is, after that it is alpha 160, then 64 32 after 64. So 64 into 5, 64 into 5, that is equal to 320. So this is 320. So let us see 5, then 10. So here also we have to write alpha 5 raised to 32, then alpha 5 raised to 64. So 5 10, 20 is 15 into 5, then 40 is 15 square into alpha raised to 10, then 80 is, this is 80 is alpha raised to 15 in raised to 5, this is 15, alpha raised to 15 raised to 5 into alpha raised to 5. So it will be alpha 5, then 10, 20 is alpha 5 again, 40 is 1 square, that means alpha 10, then alpha 5. So it is repeating. So alpha 5 and alpha 10 belongs to one minimal polynomial, that are the roots of one minimal polynomial. So after that then we will take 6 is already covered, so alpha 7, then its power will be 7 2 4 8 16 32. then 14, 28, 56, 7 8 are 56, 7 16 112, then 32 into 7 224, then 7 14, 28 is not there in the elements, so we will express it as 15 into 13, then 56 as 15 into 11, 112 as 15 raised to 7 into alpha raised to 7. 15 into 7, how much it is? So 15 into 7, that is equal to 105. So 105 plus 7 is 12, so 112. Then alpha 224 is alpha 15 into 14 into alpha 14. So here 7 14 28 is 15 is 1 is 13. Alpha 56 is 1 into alpha 11. Then alpha 112 is this is 1, so alpha 7. Alpha 224 is this is 1, 15 is 1, so 1 raised to 14 is 1, so into alpha 14. So you are getting 7 14 13 11. After that 11 you are getting again 7, then 14, then it is repeating. So the elements are 7 14 13 11 are the is one set which is called set of conjugates, which are the roots of one minimal polynomial. So for a GF16, the elements which form the same, which are the roots of same minimal polynomial are 0, 1 minimal corresponds to one minimal polynomial, 1 corresponds to one minimal polynomial, then alpha square 4 8 alpha raised to 8 are the roots of one minimal polynomial, 3 6 9 alpha 3 6 9 12 roots of one minimal polynomial, 5 10 are the roots of one minimal polynomial, f5 x 7 11 13 14 are the roots of one minimal polynomial, and their product, if you take the product you will get, x raised to 15 minus 1. So this is it for the set of conjugates or the roots of minimal polynomials, which are the elements of GF16.